In this lecture, we are going to introduce to you the language, the Python programming language. So, this Python programming language lecture is divided into two parts. So, in both the parts, again I will be assisted by your TA, Mr. Anandarup Mukherjee. So, he is going to take you through the basics of the Python programming language. So, before we start, I just wanted to highlight upon that Python is a very popular programming language at present. It is, among other applications, it is very much useful for embedded systems application development. For example, IoT based application development, Python is very popular. There are several reasons for it. One of the reasons is it is a lightweight programming language, in the sense that from a programmer point of view, first of all, it is not very difficult to learn this language. It is more like a scripting language. It is of course object oriented, but it is a scripting language and scripting like language, and it is very easy to learn this programming language. In the same way as MATLAB, for instance, is also very easy to learn, Python is also very easy to learn. And also Python is supported by different embedded systems development platforms or IoT development platforms, such as Raspberry Pi, which you are going to learn in this course. But so it supports different types of IoT devices, and also you do not need to take help of complex libraries, etc., etc. Execution is faster, and there are so many different advantages, because of which Python based programming is very important to learn, particularly if you are interested in IoT based application development. And that is why in this course we are going to teach you a little bit of Python programming to get you started. And as before, if you have your environment ready, you can, along with the lecture, you can also code yourself, so that the learning becomes better. So that way it will become a hands-on experience for you. So for all the lectures in module 2 of this course, you can do the same thing. You can keep your respective environment ready, so that you can do the the programming exercises while we teach you programming and hands-on exercises while we teach you the concepts.
In this lecture, I will be covering the basics of Python programming. So, we will just talk about how to start off with basic programming or scripting in Python, and the basic syntax and all those initial nitty-gritties. So, first of all, why Python? Now, from my personal point of view, Python, I have worked on MATLAB, I have worked on C, C++, but I find Python to be a very versatile language. The scripting is very easy. It is very easy to write the code, it is very easy to read the code, and moreover, it does not support strict rules for syntax. So, its installation comes with an integrated IDE. So, the programming is actually very easy. We will come to that in the consecutive slides. So, and for IoT, you must have seen in various online resources and lectures and courses, people prefer Python because it supports an interface with a wide range of hardware platforms, and moreover, since it is an open source platform, so you have lots of libraries, lots of collaborative work, lots of examples available online on GitHub, on various repositories. So it forms a strong backbone to build large applications. Now the Python IDE is like Arduino, is a free and open source software. So you can write various codes, integrate various modules, libraries, and so on. So it can be easily integrated with Windows, Linux, and Mac machines. So some examples of Python IDEs are Spider, PyCharm, and so on. So my personal preference, as a personal preference, I use Spider to code my programs. I'll show you a visual of spider. So this is basically spider. It is an editor for Python, as well as there is an output console over here. And for the Python distribution, I'm using Python 2.7, as you can see over here, Python 2.7, and I'm using a Python distribution using Anaconda. So Anaconda is a collection of various libraries and resources. So I find it quite useful, since lots and lots of libraries, very useful and commonly available, as well as some uncommon libraries, are also integrated with Anaconda. So that is also my personal preference. So you can obviously have normal idle based systems. So you have a IDE called IDLE, idle, and so on. So this left hand side is the editor part, this right hand side is the console part. You can even write on the console. So the problem is, you write one line, and whenever you press enter, it executes that line. So that sometimes becomes a bit problematic, whereas in the editor you write the whole code or the script and then collectively execute it. So for larger programs and systems, this becomes much easier. Now to start off with Python, simple example is, you want to print something, some statement. So you just write print hi, welcome to Python, or any other statement. The output will be hi, welcome to Python. So as you can see, the syntax is pretty straightforward. You don't need to call any libraries, you don't need any main function, you don't need other functions, nothing. You just, and remember, whenever you encounter, maybe online you encounter Python codes or anything, and you encounter these arrows, basically means your code is being run on the console, and otherwise it is for the editor. You can interchange between the two, no issues. Okay, so now to indicate different blocks of the code, Python however follows a very rigid indentation policy, right? So suppose a normal if else statement, so if true, then colon, you have an indentation, print correct, else, then again you go back, else colon, again indent, print error. So this indentation policy has to be followed mainly whenever you enter into a loop. So after one statement or this colon, you have to give one tab space indentation. So there are 5 data types in Python. Numbers, you have x, y, z equal to, you assign 10, 10.2, then you write Python. So x will be assigned as 10, y will be assigned as 10.2, and z will be assigned as Python. So remember, this x has been assigned with an integer value, y has been assigned with a floating type value, and z has been assigned with a string, right? Again, for the sake of toying around with how you manipulate strings, so suppose you assign x equal to, within quotes, this is Python. Okay, one more point, single quotes and double quotes, those actually don't matter too much, you can use them interchangeably. So over here you see the string Python is within double quotes, over here it is within single quotes, you can use either. So string x equal to, this is Python, so this string you are assigning to x, now you print x, so your output will be, this is Python. Now you want to access, now this x is an array, right? So you want to access access the 0th element of x. So you write x within bracket 0. So this will give you the very first element, that is the 0th index element, that is t. Now suppose you want to access certain selected elements, so you write x 2 colon 4, that means select from index 2 up to index 4, and index 4 will be excluded. So you have actually 2 and 3, right? So 0, 1, 2, 3. So IS, right? So IS has been selected, and this is the output of this third statement. Better still, we'll take a look. So we'll start off with a fresh console. So starting a new kernel. So you can also write over here, you write, let us say print so I can execute this thing from the editor. See, print, this is a test message, this was the line of the script, and this in white is the output. So this is a test message. Otherwise I can also write on the console itself. Maybe I write, let's use single quotes, I write hi there. So you just get the output over here directly. So as you can recall, in C or C++, especially in C, you had to call all those library functions using hash include stdio.h, hash include conio.h, and so on. And prior to printing, you had to go to the main loop definition and all those things. So nothing is required for Python. You just start writing a script immediately. Okay, so this was the first demo. Now let's see, let's assign x equal to, let's assign a string to x. Maybe this is a test, right? So this is a test, this string has been assigned to x. Let's check. I just print x. So perfect, this is a test. Now I want to assign, I want to select a specific element from the string. Let's say 0. So x0, it prints t, which is the first character, right? Now suppose I want to print a specific range. So let's say 2 to 7, right? So is space is, right? Maybe we can change it to 6 to 9, right? S space A, right? So it's fairly simple to understand. Now various other data types are you have a data type called list. So list is an ordered sequence of items, right? You can see x equal to, within the square brackets you have 10 comma 10.2 comma within quotes Python. So you can assign a integer, a float, as well as well as a string type to this various elements of the list. Then next data type is called a tuple. So tuple is an ordered sequence of items which once created cannot be changed or modified. Next is a dictionary. So a dictionary is an unordered collection of key value pairs used to contain a huge amount of data. For example, this key is 1 colon, the value is item. Then again k, the value is 2, and so on. Now again, similar to your Arduino programming or other languages, you have basic control statements. So start off with if-else statement. So you have if, then a condition, then statement 1, maybe statement 2. You can have multiple statements, but remember, if, then the condition, and then a colon. And since it follows a tabbing policy, strict tabbing policy, indentation policy, so you need to have indentation while you enter a loop. So statement 1, statement 2 have to be indented. Then whenever you are using else if, the syntax is elif, E-L-I-F, again a condition, then again colon. Then post indentation you have 2 statements, and finally else, which also has 2 statements post indentation. So this is fairly simple to understand. Another loop you consider is the while loop. You have while condition colon. After indentation you have statement 1, statement 2, that's it. Now for a simple example, suppose x equal to 1, 2, 3 and 4. This is a list, x is a list. Now for I in x, that is you iterate over the indexes 1, 0, 1, 2, 3. So for I in x, you give a statement, you give another statement. So you can modify it in various ways. We'll check it out later. Then you have various other controlling statements like break. So for s in string, string may be anything. So let us say this is the string, then colon, then indentation. If s equal to n, it compares. If s is equal to n, then it breaks, it prints s, and then prints end, right? And then continue. For s in string, if s equal to y, it continues, then prints s, and then end. Now defining various functions in Python, you can, for ease of your implementation, for ease of your understanding, whenever you are writing a very complicated function, a very large program, it is always advisable to modularize your code, as in suppose your code includes checking for a prime number, checking for a factorial, or returning the factorial value of a function, and so on. Like you have 20-30 different such functions. So, and you need to include these functions multiple times within the complete code. So it is always advisable you define that function once only and just call that function again and again. So this would not only save you lots of confusion, but also will make your code easy to understand. So this definition of a function, it can be either without a return value. So you write as def, a function name of your choice, then various arguments of your choice. You can have n number of arguments depending on the function, and then a colon, then again an indentation, and statement 1, statement 2, that's it, right? Maybe statement 2 is a print statement. So you give arguments 1, 2 and 3. Statement 1 does some operations on these 3 arguments, and statement 2 prints the result of the arguments. Another type is with a return value. So as you can see, these things are same. In the end, there is a return function. So maybe statement 2 is x equal to some operation, and eventually it returns the value of x. So the function which calls this, the point where this function has been called in the main code, it will have x returned to it, right? For example, whenever you are calling a function, suppose def example str, then print str plus this not character. So your example, outside this function, you just call this function example hi, and your output is hi. It would be better if we get to a little hands-on. Let's say I define a function as capital IoT. I give arguments as x, y, and z, colon. I give a statement as maybe a equal to x plus y minus z, right? And it returns the value of x, right? So my function has been defined. Now outside this function, maybe later on, I just call this function IoT. It will require 3 arguments. Maybe I'll write 5, 4, 3, right? And since I'll be expecting a return value, I assign this function a variable. Sorry, I assign this function to a variable. So let the variable be b equal to IoT 5, 4, and 3, right? Let's see what happens. So first we need to save this code. Okay, now I execute this code all at once. Okay, so this code has been executed, but I forgot to give a print statement. Let's print b. Now we'll execute this again. As you can see, your arguments were 5, 4, and 3. So the first 2 will be added and the third will be subtracted from the result. So your result will be 6, right? So this is your result. So this is pretty simple, I guess. Now, since defining a function has been covered, so similarly you can define various other functions. Suppose you take in 2 arguments and define which one is greater or which one is lesser. So you check whether x is greater than y, it will return x and y, else it will return y and x. So outside this function definition, you assign this function to a variable as greater, 2 values as 10 and 100, print val. So 100 is obviously greater than 10. So if this happens, it will return this one, y and x. So your output is 100, 10. So it's pretty straightforward. Now functions as objects. So whenever you're using these functions, these can be assigned and reassigned to various variables. For example, you write a function for addition, you can directly do the operation at the return statement itself. Now you print add 46, and again you assign add 46 to C and then print C. So for both the output will be 10, right? So there are two types of variable scopes. One is the global variable, that is accessible. Those variables are accessible all across your code, and these variables can be accessed outside as well as inside a function. And local variables, these are the ones which are only declared inside a function and cannot be accessed from outside. So for example, before a function, suppose the definition of a function, def example, these are some operations. You define a variable as gvar equal to 10. So this, and another variable as ivar equal to 100. So within example you can call gvar, but outside example you cannot call ivar. So basic variations. Again, you have a variable as 10. Within example variable equal to 100, you print this var, and you call this example and again print var. So what will happen is, within this example it prints var, so this var will be 100, which is locally assigned, right? So initially it was, the global variable is 10, but this overrides that value and reassigns 100 to it. But outside this function, this is not valid. So for the second print statement, it will print the global variable 10. So you have various modules in Python. So you import the module name. Now you can also call for the extensions. For example, you import random. Now the random has many such functions as random integer 1 to 10 and so on. So for example, this script, for I in range 1 to 10, as in you have a list of 9 numbers, 1, 2, 3, 4 up to 9. Value is random dot randint 1 to 10. It will randomly generate numbers between 1 and 10 and print value. So since this is random number generator, the output will vary upon each execution. So it's better you try this yourselves. So you can also try a particular function from within a module, like from math import pi and then print pi. It will just print the value of pi. Now there are various exceptional handlers in Python. These are mainly used for debugging, or in case of errors in various complicated scripts, they'll give you the exceptions, like try, then statement, except exception, statements, else statements. So one example is, while true, try. So within this try, the function will execute, these statements will execute. If there is some error, so it catches that error and accept the value error, not a valid integer. So whatever number you are inputting, it gets stored in n, it is converted into integer, and you break it, and after that this print statement executes. If you somehow erroneously input a string number to it, a string or a character to it, so it won't be converted to integer, so it will print not a valid integer. So it's better you try this code also. Another example code is to check whether a number is prime or not, and so on. So these kind of complications can be increased, and you can have multiple nested loops, you can have multiple functions, function within a function, although it's not advisable, but still. So this was it. Thank you.